In our next example, we have what looks like four inequalities, linear inequalities, but notice that the last two just simply say that x is greater than or equal to 0 and y is greater than or equal to 0. That just means we're only concerned with quadrant number 1. So that's why on this graph, all I've got here is quadrant number 1. We're not going to shade anything in quadrant 2 or 3 or 4. So we really only have two inequalities that we need to deal with, realizing that we'll be in quadrant number 1. Okay, so let's rewrite these two linear inequalities where we have y on the left-hand side, so it's in slope-intercept form. So the first one looks like it would be y less or equal negative x plus 6. All I did there was I subtracted x from both sides, and I added 6 to both sides. And I'll write down then the equation associated with that. That's the line we have to graph. And we're going to use a solid line because this is less than or equal. So let's graph this line right here using a solid line. So we've got 6 as the y-intercept. 1, 2, 3, 4, 5, 6. And the slope is a negative 1, which means down 1 over 1, down 1 over 1. So there we go. I don't even need to put the arrows on each end because we're only concerned with quadrant number 1. Okay, and which half plane are we going to shade, upper or lower? Well, since it's y less or equal, we're going to shade the lower half plane. And I'm going to wait to shade it, but we'll make a note. Just remember, we need to shade the lower half plane. Well, the second inequality could be written as y less or equal negative 2x plus 8. All I did is subtract 2x from both sides and added 8 to both sides. So this is equivalent to the first inequality, and this is equivalent to the second inequality. So the line associated with this is just y equals negative 2x plus 8. And it's got the equal sign in the inequality, so it's going to be a solid line. And it's less than, so it's going to be the lower half plane. So with a solid line, I need to go up and plot 8 as the y-intercept, and then the slope is negative 2. Negative 2 over 1. It means go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So let me graph that like so. Well, I also need to graph that lower half plane, shade it. So remember what the solution is, though. The solution is only the regions that are in both half planes. So the lower half plane of this line includes this region here, but it's not in the lower half plane of this one, so we're not going to shade it. We're also not going to shade this region here because it's not in both lower half planes. This region is precisely the solution, the feasibility set we call it. So it really may not look like it, but it actually is a four-sided figure, right? We have a vertex here, a vertex here, a vertex here, and a vertex here. A vertex is just the corner points of the shaded region. So we have the four vertices, that's plural for vertex. You can just think of them as the 4 corner points. Label each associated linear equation. Well, for simplicity, maybe I'll call this L1 and I'll call this one L2. L2 has the y-intercept of 8, so this is L2 and this one is L1. Oops, my bad. I labeled this line as both L1 and L2, so let me get rid of that and show that one. That one is L1. Sorry about that. What else do we have to do? In the feasibility region, label each vertex as an ordered pair. Okay? So this one's trivial. This is the origin. So that would be 0, 0. This one would be 1, 2, 3, 4. This one is 4, 0. And then this one right here is 0, 1, 2, 3, 4, 5, 6. Yes, it's the y-intercept of that first line. So 0, 6 is that vertex. And finally, this one we can see is 1, 2. The x is 2, and then up 1, 2, 3, 4. 2, 4. We're going to be doing this from now on in many, many of them, of the systems of inequalities that we shade. We'll graph the lines, we'll shade the region that's part of every half plane, and then we'll label the vertex points, or the vertices. All right, well, the next item, number 6, is just a vocabulary term. In the previous problem, the solution is considered to be blank because the region shaded can be enclosed by a blank. Well, it's bounded because you can draw a circle around it, because the region shaded can be enclosed by a circle. A solution is unbounded if no circle can enclose it. So obviously I could draw a circle. I'm not going to do it, but I could draw a circle around it. And it doesn't have to be a circle. It could be a square or an oval or any kind of a shape like that. But what kind of a shaded region could not be? Suppose that the inequalities required that the entire quadrant 1 be shaded. Well, there's no circle that you can draw around quadrant 1, because if you're shading it, remember, this goes on infinitely in this direction. If when you graph it, anytime you use an arrow saying go on forever, that means it's unbounded. This one, we can just shade the whole thing in from corner to corner to corner to corner. That one's bounded. All right, let's look at a simple example. Two inequalities, very simple ones actually. Y greater than or equal to 2. It's the first one, or negative 2. Well, the line I'm going to graph is y equals negative 2, and I'm going to shade the upper half plane because it's a greater than or equal, and I'm going to use a solid line because it's got the equal sign. So y equals negative 2 is a horizontal line. It looks like this. Okay, remember the x-axis is the horizontal line y equals 0. This would be y equals negative 1, and here's y equals negative 2. The next one is x less than 3. So the line I'm going to graph is x equal 3. What kind of a line is that? When you don't have a y in the equation, you only have an x? That's a vertical line. Now, go back to the inequality, and there's no equal associated with this. It's a strict inequality. So we're going to do a dotted line, and I'll write that here, dotted, or dashed line. And then this is the one case, a vertical line, where I can't say upper half plane or lower half plane. Since it's a vertical line, and let me go ahead and plot that vertical line. Vertical line, the y-axis is the vertical line x equals 0. That would be x equals 1, x equals 2. Here's x equals 3 with a dotted line. So here I don't have an upper half plane and lower. I have a left half plane and a right half plane. Since it's x less than, less means go to the left, it's going to be, we're going to shade the left of this. And upper half plane means you shade the above this solid line. So what region is in both of those half planes? Well, it looks like it would simply be that region. And yes, I put arrows on these because it goes off infinitely in that direction. I would not shade this region. It is above the solid line, but it is not to the left of the vertical line. I will not shade this region because it's neither above the solid line. Oh, it is to the, I'm sorry, it is to the left of the vertical line, but it's not below the solid line. This region is neither. It is not above the solid line, and it is not to the left of the vertical line. Okay, so that is the solution graphed. And then the question says, is the solution bounded? This is our solution, or the feasibility set. It is absolutely not bounded because it's got arrows here. You could not draw a circle big enough because these arrows will go all the way through the circle. This is an unbounded region. So it is not. No, it is not bounded.